So hello again. Now we're going to be talking about state diagrams. So state diagrams will allow us to grab a physical system and simplify it down to a digital one. So basically what we will be doing is grabbing a word problem that will represent a problem that, might exist that we can actually create a system for that will function in the same way. So I wrote down an example here, and it's I know it's not super realistic, but I wanted to create something that would help us understand kind of what we mean by states and what we mean by state transitions. So for my problem, I said that a video camera will start recording when you press record button and stop when you stop. The only thing different with this video camera is that it also has a discard button that will result in the video camera going back to its initial state of being ready to film. So if you read this problem carefully, you'll be able to identify 3 states. We can see that the camera is either recording, it is either ready to use, or it is processing the information. So now that we know that there are 3 states, we can start to name them in binary. So we have 3 states. In order to get what is easiest to use is to just name them 0, 1, and 2 for the states. So we can say that ready to use is going to be 0, 0. Recording is going to be 0, 1. And finally, processing is going to be equal to 1, 0. Notice how I do have to include 2 bits, even though the 3 will not be used. And we'll go into more detail about that later. So now that we know our states, what we are going to do is start drawing circles that will represent each state. And we label them. Now what we need to do is identify what inputs we will have and what effect it will have on the state that the system is in. So from the word problem, we can see the special case of the discard option, and we can see that there is a record button, which is the same as the stop button and the OK button in this case, because record will only be from one state to the other, and the same goes for the stop and the OK, but they never overlap, so we can just say that it is the same button that we are pressing multiple times. If you think of a system, it might as well just be a physical button that you are pressing. So we know that we will have 2 inputs, the discard option and the record /stop /OK button. For simplicity, we'll label the discard button X, and we will label the record stop OK Y. So now what we're going to do to represent these inputs is that we are going to use arrows to show what each input would mean in terms of what state the system will not become. So, for example, if we are in the ready to use state and there is no input, so both inputs are 0, so no one presses anything, it should stay within the same state, right? So here is 0, 0. So these will be in the order of X, Y for the inputs. Now what happens if you press record? Well, then it will start recording. So it'll go to our second state right here. So it'll go from 0, 0 to 0, 1 by having the input 0, 1. Now these are not equal. This is just a coincidence. It doesn't mean that if you press 0, 1 you have to go to 0, 1, as we'll see later on. So now I like to do this sequentially, so I try to go from 0 to 1 and just go from state to state. That way I feel like I don't miss anything. So if we have a 1, 0, so basically the discard button is pressed, then we're going to stay because it says that it'll return to the ready to use state. So I'll just stay here. And then finally, if both buttons are pressed at the same time, well, that is a scenario where we can either put it so that it stays in the same state, or we decide that it records anyways. So question does not mention that, so I'm assuming there's like liberty to decide, but we'll say that it stays in the same state if both buttons are pressed. So basically it cancels each other out. So now that we've got everything from state 0, 0, we'll go to 0, 1. So right now we're in the state of recording. If we are in the state of recording and we press and nothing is pressed, it should keep on recording. Otherwise, you would have to keep a button pressed for it to record, which is not usual. So likewise, we'll have 0, 0 here. Now what would happen if the stop button is pressed? Well, if the stop button is pressed, it'll go back to recording. If the stop button is pressed, it'll proceed to process that information. So that would represent 0, 1. So as you can see, the 0, 1 does not mean anything in terms of what state it's going to. It all depends on what state it is in and what input it is receiving. So that's why these state diagrams might be a little bit confusing. Now that we have 0, 0 and 0, 1, we can do 1, 0, which would be pressing the discard button, but not the record and stop. So according to the question, it clearly states that it will return to be ready to use, which is our first state. So it'll go back to 0, 0. And then finally, since we decided that if both are pressed at the same time, that is the same as if neither was pressed. So we're going to say that if both are pressed at the same time, you continue recording. It's kind of a silly thing to keep in mind, but you can either do that or you can say that one of these has precedence over the other one. So let's say we want the discard button to override the record stop button. That would mean that this one will not matter. So the Y will not matter when the discard is pressed. So that would be a variable that you would probably call X, and you would treat as a 1 if it's convenient and a 0 if it is not. So we'll go over that in more detail when we actually make K-maps for these diagrams, and there are scenarios where we have X's. But for this example, I just really want to show how we progress and make decisions from a word problem, so I'm just going to stay with the assumption that if both of them are pressed, neither of them basically do anything. So that's that state, and now we are at the processing state, and we have that if the user presses OK, which is our Y, well, first let's start with the 0, 0, which will stay in the same state. Then if the user presses OK, it'll go back to the ready to use. So that is 0, 1. And finally, we have 1, 0, which is discard, which means it will also go to the ready to use, but it will discard the information. So 1, 0. And then finally, we again have the scenario of 1, 1, which will cancel itself out. And that's pretty much the state diagram for this problem. So it's not a difficult concept, it's just easy to get confused. And it is very, very helpful for when we actually create systems that could work in the real world and are useful. So now, just for fun, let's say that we do in fact count. Let's say we count the record stop button as an override to the discard button. So if both of them are pressed at the same time, the other one, the record or stop or OK, will override the discard. So it'll automatically save, even if you press discard at the same time. So the fact that the record or stop button overrides the discard button means that whenever this button is pressed, the other one will not matter. So we would rename whenever Y is pressed, instead of a 0, we would put X1. And if we replace all of them here, so this basically means that no matter what button is pressed, if the record stop or OK button is pressed, then it'll advance to the next state. And whether it goes back to the 0, 0 state or it stays in the same state, that will depend on the discard. So that's mostly it on state diagrams. I hope this was helpful.